Welcome to an overview of statistics. Today's objectives will be to define statistics. We will be talking about how to distinguish between a population and a sample, and between a parameter and a statistic. We will also be talking about how to distinguish between descriptive statistics and inferential statistics. So a lot of definitions in this section. Please be sure to pause at any time during these videos. Go back, review, write stuff down, make your own notes. That's the joy of the pause button. All right, so first of all, let's talk about data, because statistics is all about data. Data is just any information that you can gather, whether it's from observations, from counts, measurements, survey responses. It could be a plethora of different things. If you want to press pause and read these two examples that I have put on here, you are more than welcome to do that. All right, so what is statistics? Statistics is a branch of mathematics. It is the science of collecting, organizing, analyzing, and interpreting data to make decisions. Now, depending on the course you take will depend on how deep into each of these different processes you get. So sometimes you will find that courses are very basic and just go over the basics of each of these steps. Some courses get very in-depth. It just depends on the course that you're taking. So our data can be given to us in different kinds of sets. So the first kind of data set you can have is a population set. This means that you are collecting all the outcomes or responses or measurements or whatever it is that you're gathering from an entire group of people that are listed. So if you are talking about voters in the United States, then you would say every registered voter in the United States. And there are a lot of registered voters. So it would be very difficult for us, given our limited technology with our laptops, to do any kind of number crunching on that big of a data set. So anytime you're doing that kind of number crunching, that's called big data. You will need multiple servers running in tandem to crunch all that data for you. So that's very difficult. One of the most popular population sets that is available online is the census data. So every 10 years, the United States does a census and collects data. They will literally go door to door and knock on your door if you don't turn in your the little thing that they send you in the mail. So that, again, it's a huge data set, completely not within reach for us on our laptops to work with that kind of data. So we will be focusing more on samples. A sample is just a subset or part of that population. They're usually quite small, and we will be able to use them in, say, an Excel spreadsheet or any other kind of statistical software. All right, so in a recent survey, 834 employees in the United States were asked if they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Identify the population and the sample. All right, so let's start with our population or our sample. Okay, so first of all, who is our population? Who are we discussing? Okay, we are discussing employees in the United States. And that could be quite large, right? There's a lot of people who are employed in the United States. So this would be a very, very, very big population that we are talking about. All right, but who is our sample? Who are we talking about? Like who did we get our data from? And it's those 834 people, right? Those 834 employees, those are our sample. All right, so the sample is circled here in blue, and the population is highlighted here in yellow. All right, so next up is describe the sample data set. All right, so tell me everything you know about what we have in front of us. And again, don't make assumptions, just what's in front of you right now. All right, so our sample that we have taken, those 834 people, is a subset of that population, right, of all the employees in the United States. The data was very explicit that there were 834 total people that we asked. 517 of those people said yes. Okay, so how many people said no? How many people didn't think that their jobs were highly stressful? Very simple, right? Just take 834, the total, subtract the number of yeses, and you will get your no's, which are 317. So there were 317 no's. So we could break that down even more. right? So there's a lot that we can gather from this, and then we could go forward doing whatever it is we would like to do with this data set. But that's the kind of thing that we want you to be able to look at. Identify those samples and those populations. All right, so here's one. In a survey of 410 human resource professionals, 148 of them said that job candidates were disqualified because of information found on their social media postings. And there's the source for where I got that information. I would like you to press pause and identify these next three things. Who's the population? Who is the sample? And what is the objective of this survey? All right, so the population is human resource professionals, and there are a lot. It's actually one of the top 10 jobs for women in the United States is human resource professionals. Our sample is we surveyed those 410 human resource professionals. So our population is human resource professionals, and I mean all of them. Human resource professionals. And our sample is the 410 of those HR professionals. All right, and what is the objective of this survey? Well, that could be up for debate. They don't really give us any information about why they were looking at their social media postings. They might be trying to figure out if they are disqualifying too many people. Maybe they should stop looking at people's social media postings. There's not a right or wrong answer here. So there could be a lot of different objectives for this. But at the end of the day, the main objective here is we're just going to use that sample to draw whatever conclusion it is. And we don't even know what's going on, but whatever conclusion they need to draw about the social media postings and what HR thinks of it. So again, there's no right or wrong answer here. All right, parameter and statistic. All right, so when we talk about populations, those are called parameters. So any data we get from our population is called a parameter. And if we talk about a sample, so like this one, they said the parameter was the average age of all the people in the United States. That's a lot of people, right? You don't want to spend your time trying to ask every one of the 330 million people in this country what their age is and then find the average. So what we would do is we would actually get a sample, right? The average age of people from a sample in 3 states, and then find their average. That's a statistic. So the easiest way I remember is that the P's, parameter goes with population, and the S's are statistic and sample, which is why this course is called statistics and not parameters, because we are not going to do much with populations. We are going to do more with statistics and samples, because that's what we have the technology to deal with. All right, so I would like you to press pause for a moment, read each of these, and then tell me if you think this describes a population or a sample. All right, so number one. Number one is a sample because we have surveyed 9,400 individuals aged 15 and over. Not every single one of them. Okay, so the population would have been, if we surveyed every person 15 or over in the United States, that's a lot of people. So they only took a sample. All right, number two, a freshman class at a university. All right, so this one a little tricky. Sometimes people say sample, but it's not. This one is a population because we are talking to every single member of that entire freshman class at this specific university. So we didn't say all freshmen at every university or every college. We said the freshman class at this university. All right, so that one is a population. That one's a little tricky. And number three, all right, the 34% of the stores, again, it says a random check of several hundred retail stores. So they're not looking at every single one. They're only looking at that random check of several hundred of them. So that is a sample as well. So again, statistics is a lot about details. So you have to make sure you understand these definitions. So please go again, and you're more than welcome to check out any of the supplemental videos. Go on YouTube, just type in statistics and parameters, and see what comes up. All right, there are several branches of statistics that we can break it down into. So the descriptive statistics is what we're going to spend a lot of time doing in this course. We're going to talk about how to organize data, how to summarize it, how to display that data in charts, and we're going to find means and medians and modes, and we're going to, so there's a lot of like the nitty-gritty number crunching part, and that's basically what descriptive statistics is. But we also have inferential statistics, and we will also be doing a little bit of that in this class, where we will be taking some sample data, and then we will be drawing conclusions about the entire population based on that data. And that will be at the very end of this course. Now, again, everybody's course is a little bit different. So just make sure that you pay attention to what your professor or your teacher is instructing you in your course. And again, it's one of those things where everybody kind of does their own thing. So my course, a little bit different, but we carry on. All right, so next example. So find, for each of these studies, I want you to talk. So I'm going to show you some different studies, and I would like you to identify the population and the sample, and then determine which part of the study represents the descriptive statistics. Okay, so we're looking for only the descriptive stuff, the number crunching stuff. All right, so take a moment, press pause, read it, and look at the graphic that is provided. Very important when you're working in statistics that you look at the graphics, and then we will discuss. All right, welcome back. So in this problem, the population is the responses of all U.S. adults, and the sample is those 1,500 to U.S. adults that we did in this study. Right, the descriptive branch of the statistics talks about that 18%, right? So that's where the descriptive statistics coming from, and those are coming from that graphic, right? That 18%. We could actually do some inference as well, what conclusions might be drawn from the study about using inferentials. So based on this data, I might be able to conclude that the internet has been made more inaccessible to lower income houses. Right, so based on that, that 18% don't have the internet. Now, I don't know if that's true or not, because every teenager I know, regardless of their socioeconomic state, has a smartphone these days. So again, adults. Are those people, maybe that 18% are your senior citizens who are on a fixed income from Social Security, who don't like the internet, not because they don't have it or don't use it, they just don't like it, so they don't use it. Again, that's where the inferential part can be tricky, because you really have to make sure that you are making your conclusion based on facts and not on what you feel or what you might be biased towards. So that's the fun part of statistics, is that logical part. All right, same thing. Here's a new study. Take a moment, press pause, read it, and then tell me about it. All right, welcome back. So the population in this is of all of the 401k retirement plan participants. There are a lot of Americans who have 401k retirement plans. The sample is that 1,000 people who have those 401k retirement plans. The inferential part is going to be the percentages, and I don't know why I have 2% signs. I'll have to fix that. So that's where the descriptive part comes in. That's 32%, and an inference that we might draw. So again, this isn't, we're just one possible inference you could make, is that the amount of money a person needs for retirement is difficult to determine based on this. So again, these are conclusions that we can, that we will be able to solidify more clearly as we go through the course. All right, so thank you for playing along today with our definitions. Please come back next time, and we will continue our study of statistics.